again, everyone, to another community meeting about hyperledger Iroha. So we're going to share our current updates and most interesting findings from two directions. First is internship results, and second is our news and updates on the 2.x development and design. Let's start today with, according to our agenda, with Alexei Stepanov from Innopolis University, who is doing the internship with applying Russian cryptography to the Iroha. So Alexei, I'm giving you the possibility to share.
Hello, everyone. My name is Alexei Stepanov. I'm a student at Innopolis University, and my final project at the SNE program is implementing a ghost cryptography in Iroha. My goals was first add ghost digital signature algorithm support to the project and compare its performance to the AD 25519, which already in Iroha. So, what is the ghost? In short, this is a Russian standard that describes algorithms for signing and verifying a digital signature. Just like ADDSA, the algorithm is based on elliptic curves. The key is 256 or 512 bits long, and the signature is 512 or 1024 bits long. Well, next, for this, I choose the Botan library implementation of this algorithm. Why? Because just a few libraries have support for Ghost 34.10, and some of them, such as OpenSSL, for example, support it through third-party engines, and Botan has a built-in implementation of this algorithm. In addition, most crypto libraries are implemented with C language and provide an appropriate interface, while the Botan is implemented with C++, ++11. Moreover, it has a large tool set of various crypto algorithms in addition to Ghost, and regularly updated. As you can see, the last update was about a month ago. And all of these are the reasons why I choose this particular library. This was my first time I was working with both the Iroha project and the Botan library. Both are well documented and have readable code, so there were no big difficulties, but there actually was a confusing moment. As you can see here, it's a difference in arguments between two functions, sign and verify. For example, here in generate key pair, we get a key pair type, but the verify, the sign function takes exactly this type, but the verify takes another type of public key. Moreover, the signature returned from sign function is just a string, but the verify function takes again another type. Well, it's not a big deal, but at this moment I just thought maybe I'm doing something wrong. But then I was told it's okay, so everything was good. And yeah, here you can see this is just, we need two convertations for signature to provide it to verify function, and 3 convertations for public key. Okay. At the end, I wrote a small performance test to compare Ghost with AD. The test shows an average time spent on the operations of generating new key pair, of generating a signature from a message, and confirm this signature. Also, I added a small checks how the algorithms behave when confirming the correct and incorrect signatures. And you can see the results here. Both work. Ghost is a little slower, but still fast enough. Okay, and that's it. Thank you.
Thank you. Maybe someone has any questions about this? I know it's a technical project, so yeah, probably like most of the questions might be asked by project mentors, Andre and Mikhail, if he's here. Yeah, he's here. So
Can I ask a question?
yes, you can ask questions, sure.
Do you have plans to contribute this algorithm into Hyperledger Ursa? Maybe.
I'm not sure yet. Maybe.
I just might comment on that part with the multiple convertations. It's actually this way because we optimized the types for the most frequent use cases, and most of the conversations are basically just typecasts, and where real conversion is done is when we transform hex string to bytes and vice versa. It's the scariest part of it, and the rest should be just for type safety. Like we do not want to accidentally pass one string having one meaning to another string having different meaning. So we stick to a model with very, very strict typing, and we have like this compile time checks that as a function that takes, for example, hex string public key will be only given this hex string public key. Even in a string, we can hold a binary representation of, say, private key or whatever signature. There are multiple things that can be stored in a string. So this is why we have such scary conversations.
Okay, thank you. Yeah, I knew it. It means something, and probably you don't need to verify the signature you just created. So yeah, it have some reasons for this.
Are there any other questions?
Maybe you could tell more about the benchmarks that you implemented. Like what are the technical details? Like what framework did you use, and did you compile it in release? Because yeah, I wonder why Ghost is slower than ED25519.
Actually, it was a surprise for me too why Ghost is slower than ED. Maybe it's the difference between the implementations library. Well, the test itself, I didn't use any framework. It was just a call for from a crypto interface. It's a crypto provider class. I just call each function several hundred times, and calculated the average time spent on it.
Yeah, thanks. Well, maybe we can revisit the tests well, sometime later also.
Okay.
I think it's real cool. And yeah, thank you again. If there are no questions about this project, we can probably move to the next part of our agenda is data model project, as far as I know, right?
Yes, that's correct.
Awesome. Here we don't have the intern that actually executed this project because he had something very important that came up just before the meeting. But we have his mentors who are ready to present this for him, I think.
So I think I will start with a small description of what the project is about. So as the background in Iroha 1, we had a restricted set of commands and like a restricted data model, which includes accounts, assets, domains, and commands and queries like transfer asset, or for example, query some balance of account or some aggregates, but they are hard-coded in Iroha, and it's in order to extend this, a person had to modify the C++ code and make a new version of Iroha. And yeah, it can be complicated at times. And with this project, we wanted to give more flexibility to users, and also, as we have seen with many with the projects that were like created on Iroha, and with the feedback that we got, is that users would mostly always want to add some custom query or some different aggregate, for example, based on domain or something like that. And well, we wanted to simplify their experience regarding this. And with this project, we allowed to, like, we created a simple API with a new Iroha command, which has a generic payload, which can be defined by the data model. And Iroha core doesn't know about this payload, and the data model can parse this payload as it wants. And as it is written in the document, it's agnostic. Well, like Iroha is agnostic of the semantics and contents, and these data models now can define their own state and can be implemented in any language. Well, this target language is called from C++ code as a binding. So, for example, well, here I don't have the example of Python API, but I think, yeah, I can show it later. So in general, in C++, we created such a simple API, which well, has the main method is the execute, and which gets this new call model command as an argument, and some helper methods from Iroha side in order to like enable the correct processing of the command from the pipeline point of view. So at this point, we have implemented the command and like the prototype of it. We also soon plan to have queries, which will allow streaming responses from the server side. And I guess I can show you the example data model, which was created by Mikhail. So it is a key value storage in Python. So as we see here, we have like a data model ID, so that the client can pass this ID in the call model command, and Iroha core will understand which data model has to be called. And then we have all the other logic. And yeah, this data model is about the key value storage. So, and it has two commands, which is like a set a key to a particular value and just clear all the storage. And yeah, the helper methods just do some operations with the internal dictionaries, and then save it to a file when it is required. And I guess I can show you how it looks from the client perspective. We can look at this example file, which sends it well, from the client. For example, here the client can create a command, and yeah, well, for example, create a set key value command, which is defined in this particular schema, then wrap it into the generic call model command, and then send it. So it's easy as that. Also, if you have any questions at this point, please interrupt me.
We might show the schema to yes to see the actual implementation of payload for this data model.
So I will show the proto file then. Yeah, so in like an instance of a data model imports the primitive proto from the server side, which defines the abstract command that I think I have shown it here. Yeah, this one, this message call model, which has this abstract payload and data model ID, which consists of name and version. And here it extends this payload. Well, it overrides it with a particular command, which is like set and nuke based on this data model. And so how it works from Iroha side. So here I launched one node, and we can call this script in order to, for example, set first I think I can show you that the storage is currently empty in the configuration file for Iroha, which I used to run this particular instance. We have defined that we have this Python data model, and here this particular data model has initialization argument of the file which will contain the current state, so the key value storage. And
let me add a comment, please. We designed it this way so that you could reuse first of all, same adapter, like we have an adapter for Python data models, and also you could reuse the actual data model implementation. So for example, you might have different key value storages, and in order to prevent conflicts between them, so they use basically the same code, and you can pass different initialization arguments to each of them. So this way they can distinguish between their instances in one Iroha node, and they can use different like configurations, storage paths, and everything else. And they can even use different data model names and versions, because that, as Andrei already showed in our interface, we have a function that returns a list of supported data model names and versions for each module. So this way, this list can be dependent on this initialization argument. So the same code can serve different identifiers in the ledger. So the system seems very flexible.
Yeah, thank you for the extensive description. Yeah, I think I can send the command in order to show how this particular data model works in terms of this file storage. As the script allows to send these two commands. So in this example, I will set the key 1 to value 1. And here from the logs of Iroha, we can see that it processed this command, which has this payload, like set key 1 to value 1. And then we see that the block storage, like the key value storage was changed, and then it was saved to this persistent storage. And as we see, the file also changed. And well, similarly with the nuke command, we also see that the key value storage was cleared, as well as the file. And yes, in practice, this allows the Iroha administrators, or well, the creators of the network, to create the data models based on their needs and implement it in the language that they are comfortable with, when C++ might be not always the easiest language to work with. I think that's it for the presentation. Thank you. And yeah, if you have any questions, please ask.
Yeah, may I ask a question? Mikhail told that despite the fact that different peers can have different data models deployed on them, they still can communicate. Does it mean that they have an ability to somehow proceed with unknown data models, or it means that they will skip commands and transactions with unknown data models? Can you maybe repeat if I didn't catch, or add more information about that?
So we assume that all the peers should be configured in the same way. This is somewhat, I think, similar with the Fabric, where you can have multiple implementations of the same like smart contract in their system, but here we are talking about modular data models. So yes, it is completely all right to have like different implementations of same data model as far as they do the same thing. I would say. So that as far as the state is consistent between them. And regarding unknown data models, we didn't mention it here, but we have a command that registers data model on the ledger, and it kind of enables this data model from starting from the point when the command was executed. And this, as this is a project still in development, we do not have the rest complementary commands for lifecycle management of such data models, because we would expect that versions would advance and some data models would become unnecessary, and we want to remove them, and we at some point we will want to add another data model like to the already running network. And for these kind of situations, we have we have in plans lifecycle management commands like registered data model or unregistered data model. So all the peers process these commands like any other commands within a block or a transaction, and they simultaneously switch the set of available data models, and it's up to system administrators or whoever is running the nodes to ensure that the required data models are configured in the configuration file, and they are consistent with the rest of the network. Does this answer your question?
Yeah, just small additional question to better understand. So all peers should have the same model definitions, but may have different model implementations.
That's right. So the model is identified by its name and version, and then it's up to the node administrators to ensure that this code that is actually linked or configured to run as this data model does what it is expected to do.
And by the command that you mentioned, we can add new model schema and implementation to the running peer.
That's correct.
Okay, thank you.
But to the running network, I should make a correction. So with current implementation, we yes, sorry, we only have this configuration in the config file. So currently we would have to restart the node, but it's only an implementation issue, and in the future it could be done, for example, with maintenance endpoint.
Mm-hmm. So the
there's
comment
no
will be
problem.
add. So the comment will add it to the peer, and it will be distributed across the ledger.
No, currently we do not think of this distribution mechanism. So each node should be operated separately. So each node should be configured
So you need
so-
to add this schema and implementation to all the nodes in the network
this
by this command.
This registration and the addition of a data model consists of two main steps. And on the first step, we need to make the node aware of a data model instance. This is what we do in the configuration file. We tell that here you are some code that is able to execute some data model instruction, specific as the data model instructions. It supports some identifiers and data model identifiers and versions, and you should query it for which ones does it support. And the node does this. And the second stage is when we actually enable this data model from the ledger. This should be done from this way from the ledger because we need consistency across peers. Because we can imagine a situation when we have such a version like update going on, and in this moment, users execute commands on these modular data models, and some of the nodes already have transitioned to a new version, and some did not, and then we have inconsistency and actually malicious behavior. And to prevent this, we first of all ensure that all the nodes have the required data models configured, and then we atomically do this enablement and disablement of data models available to users. This is done through a command on the ledger, actually.
Okay, so if there are no questions on this one, we have our third and last topic for today. As I understand it, Nikita will present a new feature for Iroha version 2, right?
So because Igor is absent today, I will describe a feature that was developed by Igor. It is support of different key types in Iroha 2. So previously we had only one possible way to configure Iroha public and private keys, and we also use some format of bytes array. It was not good, not in terms of functionality, not in terms of user experience. Yeah, so we made a decision to move to multi-hashes and to use different possible types of public and private keys, and also to change the representation. To do it, Igor developed a new command line interface application, Iroha Crypto CLI, that can be used to create additional public and private keys. It will work with different crypto algorithms supported by Hyperledger Ursa. So we still wait for the new version of Ursa to be available to support recent additions. And also, if you have some algorithms that are not provided by Ursa, you can ask us to consider implementation of such algorithms by ourselves or by contributing to Ursa. And Igor also updated our documentation. So now you can see how you can use different tools like Iroha Crypto CLI to generate new type of keys with new format, like in multi-hash, and you can use them in Iroha configuration. It can be Docker Compose or JSON config. So we will work with it. We tested, for example, ED25519, but you can try other different algorithms. It should work as expected, and we will now should not depend on the algorithm. You can use any algorithm supported by Ursa. Yes, I think that's all about different key types. And also we had a new RFC, and we made a big discussion about this RFC. It is about Iroha special instructions DSL. So Iroha 2 will have instructions instead of commands from Iroha 1, but we were inspired by Iroha commands and command query separation pattern. But we also were inspired by Scratch from the MIT as a way to build some complex instructions using basic instructions as building blocks. So here we made a decision to provide some out-of-the-box instructions, but also to provide some composable types of instructions like pair, sequence, if, and we may also add some more out-of-the-box instructions later. And have an ability to build some custom instructions from these composable types. As an example, we had some tests in Iroha DSL model. So as you can see, you can build some complex instructions in place using some pair composable types, Iroha query executions, etc. And you also can define your own structs and implementations with not hard-coded by some arguments for your business logic, and you will need only to provide some method to transform your instruction into Iroha special instruction composable type, like if in this case, before you send it to the peer. This way we provide an ability to build some complex instructions on the client side, but still we have an ability to check all the permissions and all possible actions on the peer side. Yeah, I think that's all. Maybe you have some questions.
I think just need to probably a little bit clarify here that we need to finalize this decision, right? To continue with this, with some details of the decision, how it will work, how it will be finally implemented. Mm-hmm.
Because we do not have a 2.0 release yet, it is still under consideration and may change. And if you want to participate in our discussions, you can go to our RFC page and look at our open requests for comments, comment on them, and even if you want, you can create new requests for comments with your ideas. So we will comment it, maybe we will accept it or we will decline it. You also should use our proposed instruction how to create RFC. So it will help us to do not ask some obvious questions and to only discuss some really important stuff.
You can ask your questions in asynchronous mode. So,
by the way, I also have a little piece of news. I was contacted by a person who translated Iroha version 1 documentation into Turkish, and now I'm again starting to trying to implement the translation stuff. So yeah, soon I think soon we'll have localization for Iroha documentation. Hopefully. It will be just as it was decided for Hyperledger project. It's going to be on GitHub, so it's basically going to be just a branch of some sort. So not branch; it's just another translations. So it's going to be easy for everyone to translate soon enough. Yay! That's a little piece of news from my side.
Okay, good. So I suppose we run out of questions and topics, right? So it's a good time to wrap up.